these of the world came here today, because it's come from Norfolk down here today, which I think is some view of the disruption as quite a heroic thing to do. So Mark is very much involved with the development of SEB. We've been looking at developing some new inspection vehicles based on the 153 units, which have recently been withdrawn, or a lot of them have recently been withdrawn from service, both to support truck patrolling and indeed longer term do many other exciting things, which I'm sure Mark's going to tell us all about. So over to you, Mark.
Super. Well, thank you very much, Andy, and thank you very much for having me here. Yes, I'm Mark Chestney, Senior Programme Manager on the Infrastructure Monitoring Programme. That was set up around about 3.5 to 4 years ago to revolutionise the way that Network Rail gathers information about its infrastructure using trains. My career actually started only a few hundred yards from here, as I was telling Andy earlier. And you mentioned Nigel Fairbrother earlier. I was in the same office as Nigel Fairbrother in 1994. So it's nice to be back there, but I don't think I've actually been back to Cardiff Station since then. So here to talk about the Network Rail 153 fleet, which is particularly good timing actually, because only in the last couple of weeks we've actually had confirmation that Wales and Western will be getting a 153 visual inspection service for S&C from the middle of next year, basically. So about 6 months away, you should have a service running around Wales and Western collecting S&C information. So the overview, got about 30 odd slides to go through, but there's lots of pictures in there, so don't worry. I think we've got plenty of time at the end for discussion. Should take around about sort of 35, 40 minutes, something like that. If anyone in the room wants to ask a question as we go through, please do, because I'd rather have debate. If that's too difficult, I will say I will answer it at the end, and then hopefully by the end you will get to ask me it, and I'll get away with that one. But what we're going to cover is basically a little bit of background, why the VRUs are needed, and why specifically 153s as well, how they were converted, so how we built them and how we brought them into service for that initial proof of concept, how they've been improved over time. So there's been quite a lot of work done on them since they were first introduced to make them better. The service that we have today and the sort of service that I think will be sort of happening in 2025, what they were designed initially to do and what they can be used to do now, because they're actually two quite different things, and then some questions and discussions at the end. So going on to why were they needed. So Tyler Byrne killed on Southern in early 2021 while doing an S&C inspection. Also, lots and lots of reported near hits associated with S&C inspection and patrolling as well. And I am sure lots and lots of unreported near hits as well. Lots of slips, trips and falls. You know, when you're wandering around the railway with a torch, looking down, not looking where you're going. Lots of slips, trips and falls associated with that. And also on Eastern, particularly, there'd been a number of derailments over the sort of past 8 to 10 years, which are associated with S&C, particularly with not having decent quality loaded geometry information. So the S&C, when you went to the manual inspection with your potentially with your gauge, well, you don't need a gauge for doing a BVI, you would look at it and it would look fine, but when a train ran over it, it moved around and it was behaved in a very different way to what it looked like when you were doing a manual inspection. Also, in terms of the railway moving away from having people actually on the railway doing inspections, there's a big push for boots off ballast, a big push for reliability-centred maintenance and having better data for that, and also, of course, a number of access constraints as well. All of which meant really that we had to start looking at doing things a little bit differently. But in summary, really what the drive for this for is safety of the workforce, safety of the asset as well. So the exec challenge that was laid down, you can read that there yourself. That was laid down in March 21, so fairly soon after the fatality on Southern. But the key thing there is 6 months. What can we do in 6 months to make a change? Now, that's taken me sometimes more than 6 months to get a PO approved. So that's a pretty, in Network Rail, that is a pretty big challenge to actually get something out there on the railway, doing something different within a period of 6 months. Yeah. But thought, well, try, and lay down a challenge. Challenge is a good thing to drive different behaviours, I think. So the requirements, and this is the sort of system requirements for the proof of concept. Like I say, Southern is driven by Southerners and Easterners as the sponsors, because they had the sort of two issues that were driving this, and they've been very much involved from the start. Now, clearly, the key thing for this to be a success was the ability to do an inspection of BVI of S&C from one's desk rather than going out doing it another way. So image quality, really, really important for this. If if the imagery is grainy or the angles aren't right or anything like that, people are never going to buy into it. So that image quality is absolutely critical. Locational accuracy is another one. So if you have a dip joint in plain line and the train tells you that's there, and you know that the train is accurate to within 20 metres, doesn't really matter. You can be pretty, you can work out where that dip joint is going to be. You've got a dip joint in S&C, and that's in Paddington through, and that could be 20 metres that way, 20 metres that way, 20 metres the other way. It's going to take ages trying to find it. So locational accuracy of the train and repeat accuracy as well, absolutely important. But also having the confidence that it's accurate. So the yellow fleet as is today, round about 20 metres locational accuracy, but not all the time. So sometimes that might go out, that might be 50 metres, another time that might be 5 metres. And that variation can cause people that are maintaining the track some pretty big headaches, because if you're told a particular defect is there and you absolutely know that's within 20 metres, you've got a bit better chance of finding it. But if that could be 50 metres or whatever, then obviously that throws in a whole lot more variables in there. So having confidence that what the system says on the tin it actually delivers, very, very important. Getting the data quickly. So if you're a TME, you're sat there and you see a measurement train go trundling past your window, you want to know that you're going to get that data within a reasonable time and within a time frame that the deliverer is actually committed to as well. And in this case, because the BVIs, the trains are running quite regularly, it's not like an annual inspection or something like that, you need it pretty quickly. So the bar was set to have that information in hand within 24 hours. So that basically meant that you wouldn't have a lot of time to do a lot of post-processing of that information. But also, the end user requirements were that when they get that information in hand on their desktop, they don't have to do a lot of processing either. It's ready to use there and then. So as soon as it lands, you can look at it and you can start using it. Eastern also had a requirement for track geometry measurement. So typically doing an BVI and S&C, you don't measure track geometry, but because they had the derailments in their area, a little bit of pressure from the ORR as well, they had a requirement for track geometry as well. And Southern also had a requirement for thermal imagery as well. So they got the third rail, lots of cables, lots of issues with cables and overheat and get hot and all that good stuff. So relatively easy to deliver thermal imagery now as well. So they had that as well. And I suppose bringing all that together, it absolutely had to have a user-friendly front end, because if it's not easy to use, if it's not intuitive to use, people won't use it. It's as simple as that. And we didn't want to have something that required specialist IT equipment or something that required 6 weeks of training to use it. It's got to be simple, intuitive, and just obvious to use. So that was a really, really important thing, was that front end. And then putting, I suppose, my own sort of blinkers on to a certain extent. From a delivery perspective, we wanted it to be driver-only operation. So a number of the existing yellow trains have a number of technicians on to switch things on and fire things up and monitor this and press a button here and do that. And the more people that you have involved in that delivery chain, the higher likelihood is that it's not going to deliver, because someone is going to have an off day, someone's going to be off sick, someone maybe isn't as skilled or competent as they should be. So the less people on the day that you have delivering that service, the better. So really, really important that we have driver-only operation. And when I say driver-only operation, I mean driving is all they do. they're not switching things on, switching things off. They're just literally driving the train. So when they fire that train up, everything automatically fires up and does its thing. Clearly, it needs to go anywhere. The aspiration was always to, well, my aspiration, I don't know if anyone else was, but my aspiration was always to roll this out nationally. And we're sort of starting to get there somewhere with that now. So that was, couldn't have something that could only fit in sort of certain areas. It had to go anywhere. So there's obviously gauging issues around that. If that's going to be claiming in the platform and stuff like that, that's not going to be any good. Also, length as well, quite an important thing. The idea being that the focus of the 153 VIUs is very much around, sort of station areas where you've got lots of S&Cs. So you need to be able to shoot in and out of platforms quickly. If you've got a 10-car train doing it, it's not going to be very quick and easy to do that. So the shorter, in this case, the better. Tends to also lead to diesel propulsion realistically being the only option. In sort of 6 months now, we weren't going to sort of develop a hydrogen cell or anything like that. So really diesel was the only viable option at the time. And speed as well. So in essence, the faster the better, because we wanted to be able to fit in with traffic where we could. Now, don't need something that does 100, 125 mile an hour, but something that can only do sort of 30, 40, 50 maybe could be quite restrictive. So we wanted something that was fast enough to fit in with traffic and could sort of accelerate up to reasonable speed as well, and not work in a possession. So that's why it's really important that they could sort of fit in with traffic and do this, during the day when passenger trains are running, and just fit in and not take away possessions from the maintenance teams at the end of the day, because that's the time that they spend and fixing the track. Also be able to run day and night as well, so it can record whether it's light, sunlight, or whether it's dark, record at night time. So of course also in tunnels as well. Reliability, absolutely critical, because they're running frequently. BVIs tend to be at quite a frequent sort of frequency, 7, 14, 28 days or whatever. There's not a lot of opportunity to do recovery runs if you're running at that frequency. So they've got to run properly out of the box and record on that first run. Effectively, you get one bite of the cherry. Unlike if you're running something every 3 months or 6 months, you've got a lot of time and flexibility then to run it again. But with these, you haven't. So they've got to be reliable. So the platform, as in the train, has got to be reliable, and the kit on board has got to be reliable as well. And then the final thing I had on the list, which is a little bit strange and isn't flippant at all, they've got to be sort of nice. Because if you try and roll out something that people have already built up a negative attitude about, you're never going to make it a success. And I'll pick out the MPV. I was under quite a bit of pressure to try and convert some MPVs. Everyone I spoke to hates MPVs, right? Because they're unreliable, they keep breaking down. Multi-purpose vehicle. So there's a geometry measurement multi-purpose vehicle in existence at the moment that is inherently unreliable, right? You're never going to be successful if you start off with something that everyone hates from the start. So there had to be something new, fresh, different that got people quite excited.
Do you want questions now or at the end?
Shall I take written questions at the end, but questions in the room now, if that's okay?
Yeah, that's fine.
That'd probably be better.
Yeah.
So why choose a 153? So this is a very common question that I get from some very, very senior people. And when they say, why ever did you choose a 153? They're a dog box. So apparently the dog box, they were called dog boxes when they were sort of in passenger service in the 1980s. They're noisy. We used to get one to school. The seats are really uncomfortable. Oh, they're bouncy. They were built by Leyland Bus. God, how could they be any good? I really don't like them. Well, believe you me, we don't get any complaints from the generator or the cameras or the batteries or any of the monitoring equipment on board. So whilst they may have not been the greatest passenger train in the world, they're a pretty damn good train for doing actual infrastructure monitoring. But why did we choose one? So I'd like to say that we did thorough market analysis, options analysis, return on investment modelling, all that great stuff to put together an exec paper and come up with an answer that defined that the return on investment would be best for the 153. But in reality, we didn't have time to do that. In reality, the 153 was really the only thing that was viable at the time. So it was fortuitous, really. And it was fortuitous for a number of reasons. They're not an enthusiast favourite. So if we'd have started converting something that there was a preservation group for or something like that, we'd probably come across quite a bit of resistance. Not a vast amount of people out there who love the 153s who say, you know, you shouldn't be cutting them up or putting generators in them or taking seats out or anything like that. So that was a good thing. They can go anywhere. So initially there was quite a bit of pushback around the passenger steps, because they'd been where they had been previously approved to run, that had been rescinded because the passenger steps had hit some platforms. Easy answer to that. Took about half a day, take passenger steps off. Job's good.
They were an afterthought originally.
They were an afterthought originally indeed, and probably should never really been put on there. Obviously no passengers are going on there now, so we don't really need passenger steps. Great industry knowledge about them as well, because they're still being used in some places. So there's a lot of knowledge about the operation of them. There's a lot of drivers out there that can still drive them, and there's a lot of drivers out there that actually quite like driving them as well. There's a lot of people that can maintain them. There's a lot of spares availability. There's other ones that are being scrapped as well, so there's spares available from there. They're an incredibly simple unit, basically a Cummins lorry engine in there with an automatic gearbox, nothing fancy at all. There's lots of wiring in them and whatnot, but very simple piece of kit. There's plenty of space underneath them as well, so you've got plenty of space to fit your kit underneath. I say that fast enough, so we possibly could have benefited from something slightly faster. But they'll do, on a good day, they'll do 70, so they will sort of fit in with traffic. We do need to have to sort of sneak them out into sidings every now and then, but they will generally fit in traffic where there's a sort of more intense service. Obviously, on sort of West Coast Main Line and something like that, they're going to struggle. Like I said, drivers seem to quite like driving them as well, which is beneficial, because if you've got a measurement train that no one wants to drive, it's never going to be a success, because they're always going to opt for driving something else rather than that. And a key one, of course, is the ability to change ends quickly. So where you're shunting in and out of platforms and stations and reversing back and forward, the ability to walk through that train and quickly fire it up and be shooting off, going back in the other direction, really important. And that is where the difference comes in between something like this compared to a loco, where you have to get out of the train and get on the track and get back in again, or a tram or an MPV or something similar to that. So a passenger train, single coach that you can walk through, significant benefits there. So converting the vehicles. Just stick some cameras on the bottom, that'll be very straightforward. But you can see there was quite a bit of work involved in building these, quite a big job. So despite the fact that these ones come from EMR, and they relatively recently come out of service within the sort of last 3 to 6 months, something like that. But even so, there was quite a bit of remedial work that needs to be done before we brought them back into service. The picture on the left there, you can see that is floor strengthening to put the generator. So the generator pretty much sort of goes in the middle there. But the approach was really sort of do a bare minimum for the proof of concept, because we wanted to get them out there quickly, didn't we? You know, want to minimise the amount of money we spend just in case they didn't prove themselves. We got a dispensation for a significant amount of overhaul work as well, so allowed them to run a little bit longer before doing any massive sort of overhauls of the underframe and everything. And you can also see on the right hand side there's quite a bit of wiring remedial works that needs to be done, but also some installation of new wiring as well. But this just gives a purpose of these pictures, just to give a flavour of just sort of how much work is there, and it's not just a case of sticking a couple of cameras underneath them.
I assume they were new enough not to have asbestos in them.
That, you're absolutely right there, because there's quite a reasonable amount of sort of records for these vehicles and what's been done to them over time. And we did at a very early stage confirm there was no asbestos there, because I think if there had been, that would have been a no-goer. I think there's no way that we could have done it within that sort of time frame if they. And I think the ongoing conversion costs, if you were to convert more, if they've got asbestos in them, it's just going to be prohibitive as well. They're probably just best for the scrap it, really. So the first VIUs, like I said, come from so when I say VIU, that's visual inspection unit, which is what most of the 153s are. First ones came from East Midlands Railway. As you see here, this is the first one that came into service. We just removed the EMR references from the outside and do any livery changes or anything there. So photo on the left is the business end. You'll see there that the camera at the top is the forward-facing video, so that effectively sort of gives a patroller's walking eye view of the track, and then the camera beneath that is the thermal imaging camera. And then on the right picture there, you've got in that pod, so you've got those pods looking over a rail. You've got a lighting system in there, and then you've got a camera that faces directly down onto the head of the rail, and then one that's looking at either side of the web. Then so looking underneath the train, so the picture on the left-hand side is the Vista track geometry beam. That's a sort of self-contained beam. The two tubes that you see on the left and the right-hand side there contains the lasers, which fire down to the pick up the rail gauge corner basically, and that's where your geometry measurement takes place. That's a purely optical system, so it's nothing. There's no mechanical contact with the rail at all. And then on the right-hand side, as you know, earlier I mentioned about locational accuracy. So that system is built by a company called Machines with Vision, and that's called Rail Lock. And that determines exactly where the train is, where the images are sort of in space. And how that works, it's a little bit black magic, and I won't be able to explain it exactly, but it basically uses sort of random track features. So whether that might be the ballast or cracks in the sleeper, or a bolt turned a certain way, anything like that. Basically uses that through that camera, and that'll do a few runs. That'll pick up all of this information. They'll then process that information. Then the next time that goes out, that'll know exactly where it is. And now you're going to say, well, what about if you tamp it or do something or whatever? If you do a full relay, that's going to get lost the next time. You're going to have to do 3 or 4 more runs and process the data again, so that knows where it is. But if you just tamp or do some spot re-sleepering or some re-railing or whatever, there's enough features that are left there that can still know exactly where it is. And that is, well within the 1 meter accuracy level that's required. So a little bit of a look at what we done inside. So you'll see the generator in the middle there, which is pretty large, but that's got plenty of redundancy in it to add more kit should we need it in the future, and add more sort of capability to the train. That generator actually comes to pieces. That goes through the gangway and out through the door, and we have to build a special jig to get that in and to get it back out again.
So all the equipment on the train is driven by the generator?
All the equipment
hasn't affected the train at all?
No, not at all. No. So the train itself, the engine and the gearbox and everything is untouched. Everything on the train powered by that generator there. But you'll see that you see also that you generator there to put a hole in the roof of the exhaust, so that's where the generator exhausts through the roof. That's actually fed from the same fuel tank as the train itself, so it's not separate fueling or anything like that. You can see the holes in the side, or the filters in the side of the train there for the air intakes for the generator as well. Those little grey, the big grey boxes down to the dark grey boxes down to the left of the generator, they're the battery banks, which are actually charged by the generator as well. And that's all automatic. So as soon as the driver turns the train on, this is all comes on automatically and does its thing. Those batteries are talking to the generator constantly, so the generator is turning on and off as required when power is required by those batteries. At the end of the shift, the train will come to a stop, the driver will get out, they'll shut that down. This continues to monitor what's going on and will continue to pump data off the train. The generator will keep charging the batteries. So basically, the driver doesn't have to sit there and wait and get that data off, or someone come and take it off. It all gets pumped off the train into the cloud automatically. So that's available for the end users. The video imagery turns on as soon as the train starts to move. So once the train is in motion, the cameras start recording. The laser geometry system, because of the sort of laser safety requirements and what have you, that clicks in at 5 miles an hour. We're actually trying to look at if we can actually turn that on at a lower speed, but at the moment that's actually set at 5 miles.
That's the same as existing trains, isn't it?
That is, yeah. But because these are doing something slightly different to the existing trains, particularly in S&C and platforms and stations and what have you, we're missing some data where they're just trundling around at below 5 miles an hour. So that, what I've just talked through there, that was sort of the initial proof of concept specification. And we sort of had that running in service for around about 6 months. And like I said before, everyone has sort of been involved in all sorts of stakeholders, very much involved in this from day one. So we were constantly sort of talking to the end users of the data, talking to the maintainers who are around maintain these trains for us, the kit supply, all the equipment suppliers on board as well, drivers and whatever, to get feedback on how that was working. And one of the key things that we got back initially was that the quality of the imagery was pretty good, and it sort of works, and the concept is sort of proven, but it could actually be a little bit better. And one of the key ones was the imagery of there wasn't a single image of the 4 foot. So as I think I was showing you before, there was the 3 cameras looking down at the rail. So to get an image of the 4 foot between the rails, 2 camera images were stitched together, and that just wasn't particularly liked. There was also, if you were operating on a very, very sunny day and you went from bright sunlight into, under a bridge or into a tunnel or something like that, the sudden change in light conditions would tend to confuse the cameras for a few meters as well. So you'd lose a little bit of footage, which again was something that we wanted to overcome. And also the image of the web the angle was basically too steep. So it was looking down like that rather than looking in more sideways as well. So there's some of the features that you want to look at, some of the track fixings and what have you, couldn't be seen at the sort of the desired angle for doing an inspection. So we thought, well, what can we do? So what we actually did was move all of that equipment that I showed you that was on the front of the train, so the pods that were looking down under the train, and added additional camera as well. So you'll see there's a new lighting array with 4 very sort of high spec lights. So that, because that's now under the train, you don't get that variation between bright sunlight and tunnel or whatever. That's a constant artificial lighting arrangement all the time, so the lighting stays similar. And then we've got 7 cameras that you can see along there, with the one in the middle now shows the 4 foot between the 2 rails in one image, and then you've got the other 3 cameras but looking at each rail, and they've been adjusted slightly, so they actually give a much better view of the web and the fixings and everything as well. So a few other improvements as well. The putting all that equipment underneath meant we had to move the air reservoirs from under the train into the train as well. We also took that opportunity to do some other improvements. Like I said, very important that the drivers want to drive these trains, so we made a nice breakout area for them, seating area, put in a proper modern toilet area as well, kitchen, various improvements to the doors, so when the generator is running, that's quite quiet for them as well. Because like I say, we wanted to sort of be a nice place for them to be, because they're critical to the successful operation of them at the end of the day. We also, like I said before, had some conversations with the maintainers and sort of rolled out a few improvements to make basically enhance the maintainability as well. So at this stage, we also introduced the new livery, so the blue livery rather than yellow livery. And this is a question I get lots and lots. Why are they not yellow? Really, because I just wanted to do something different and make them look different from everything that's been done before. There are some other reasons as well, but I won't go into them yet. I might go to tell you them. Right, so like I said, they were rolled out, done the bare minimum to prove the concept. The concept was proven pretty quickly, particularly when we did the other improvements as well. But now, in the last 6 months, we've really been concentrating on making them fit for the next sort of 10 years. The kit on board was always designed for a 10-year service life, but the vehicles weren't, because they were all getting towards basically needing a fairly heavy overhaul. So we've taken the the vehicles that are in service. We've taken them all out of service one by one and done a C4 and C6 overhaul, which is basically the body and underframe. As actually you'll see from that picture there, once you start prodding around, you tend to find quite a lot of things that you didn't quite expect to find. And they are, you know, they're I wouldn't say severe corrosion. I'd say that that's certainly recoverable, but we're doing a proper full job on them to make sure that in the next 10 years they don't need to be pulled back out of service to do any further.
You can't expect a lot to be
You
rusted.
can you? That's exactly sort of like a mini metro or something like that.
Yeah.
So yeah, so that's all the corrosion being cut out and repaired. Also underframe, so bogie is overhauled, new overhauled engine and gearboxes and whatnot as well. So these will definitely be a reliable vehicle for the next 10 years and won't need to be pulled out of service for long periods of time to have sort of unforeseen heavy maintenance work done. The new vehicles that we're introducing, when we do the conversion, we also do the overhaul at the same time as well, so we never have to pull anything. We just do it all in one big hit, and then that gets rolled over and into service. It's good to go. And what we're also doing is making sure, as I was saying earlier, Andy, there's quite a lot of variation in some of the trains in the rest of the monitoring fleet, and with these, I'm absolutely determined to keep them all the same, because if they're all the same, you have that flexibility where you can just bring them in and bring them out, and the one that's in Wales and Western can do exactly the same bit as the one that's in North West and Central, what have you. So as we find things to improve and we do mods, we absolutely roll that out to the full fleet. And to support that, really, really important to have the right sort of commercial arrangements in place to support that growth, because we are getting more of these. Initially, to get the proof of the concept, you know, sorted and through, that was all on a best endeavours basis, which was the right thing to do then, because that led to an incredibly high level of flexibility and commitment, and people really want to make it success. But really, we need to sort of drive that like long-term performance improvement, all that sort of thing. So we now got contracts, long-term contracts in place for the lease of the trains, for the lease of Porterbrook, maintenance, which is done by the RAM, and the repairs. The operations is done by COLA, so they actually drive the trains and also plan them as well. And then the monitoring equipment, which is delivered by a number of different companies, but that's headed up by DG8. Excuse me, one smoke drink. So the service today, we've got 3 BRUs out there in service, one on Southern, one on Eastern, and a spare that we've been sort of sending around on special there and everywhere. And then we've got the track condition monitoring unit, which is a 2-car 153, which is currently being commissioned. And that is basically it's basically a mini PLPR train. So that's to try and free up the rest of the PLPR fleet, so that can concentrate on doing the sort of the high-speed long distance stuff, and then this can be used to do some of those recovery runs and also to focus on delivering some of Anglia's requirements as well. But that is in the process. That's been running around for quite a while now, being commissioned, and hopefully that will be out there and actually gathering information and commissioned early next year. So the service plan for 2025. Really, really keen to move the Eastern Southern units onto working timetable paths. So doing it on the short-term planning does take quite a lot of effort. And it also runs a risk of it being cancelled last minute as well. Whereas if it gets on into WTT paths, there's a much higher chance of it actually running and being a success. Like I mentioned before about the TCMU, bringing that into BAU service next year as well. I think I did touch earlier. Did I mention the TRU? No, it's TU, wasn't it? Shit. So sorry, yeah, the track recording unit, the class 950 or 150 track recording unit that Network Rail runs around to do geometry measurement on the lower used lines, that is coming to the end of its life. That has some fairly serious corrosion issues, and also the equipment on board that is not supported by the supplier anymore. So we're running quite a risk with that at the moment. So the plan is to replace that class 950 with a 153 TRU next year as well, which again brings with it benefit of having a common platform. So you then got, common spares holding and common competencies for maintaining these trains as well. And then, as I mentioned before, Wales and Western will be getting their VRU service middle of next year, as will North West and Central. And Scotland, we're in sort of fairly mature discussions with them now as well, and it's likely that we will have a train built for them by the end of next year as well. So that will bring us up to a fleet size of 7 trains made up of 9 cars. So, challenges. That was quite a challenge. As you can see, I don't really need to say much more about that. Touch wood, we've only been hit once by vandalism so far. And I bet now that I've said that, we get hit within the next week. Absolutely.
Yeah, same thing, it's undesirable.
Exactly, yes, that's right. So other challenges, getting the track geometry system approved has been quite a challenge. It's approved as an accurate system, so the traces are confirmed as being accurate, but it's the way that it generates exceedances still isn't approved. And of course, it's also an unattended system, which, as Andy knows, comes with a number of challenges as well. We have got a pretty clear way forward with that now with the TA, and I am.
Well, I think RS, it's been raised at RS, it's been, and the industry is actually quite comfortable with the concept on the grounds that this is going to be more reliable. We're not going to get so many false alarms. But we do need to practice.
I think, we've got a clear way forward with that, and I'm confident that certainly within the first half of next year, this will be a fully approved compliant system for measuring track geometry. Therefore, can be what you rely on to actually make safety critical decisions on. I mentioned the working timetable paths before. We've got a few of those in place now. That has been quite a challenge to get there. Lots of people are involved in that process. And once that is in place, it does bring massive benefits, but there's no doubt about it. It certainly has taken longer than I would have liked it to, but at least we know that we can do it now. A few other things. So myths and legends, that's been quite a challenge as well. So Liverpool Street Station, a real big headache for Eastern to patrol at Liverpool Street Station because of the access, restricted access there, basically. But when you go back a year, talk about Liverpool Street Station, you can send a 153 in there. They'll be filling the place with smoke. They'll be setting all the fire alarms off. They'll be hitting all the platforms. They'll be doing this. They'll be doing that, doing the other. Right. Well, none of that is actually true, is it? So that picture on the left there, we arranged a special gauging run where we took 153 without any steps on, admittedly, but they all don't, none of them have steps on now anyway. Took it into all the platforms in Liverpool Street Station and proved that didn't hit anything at all. And surprise, surprise, when that was in there, the station didn't fill with smoke and that didn't set all the fire alarms off either. So you can't always, you've got to keep pushing, I think. You've got to keep pushing. Don't take sort of no for an answer. Because now we've run, and this is one of the working timetable parts actually, we've run a shift between Liverpool Street and Norwich. This is about an 8-hour shift, so not particularly particularly long. Some of them were around a bit long that, but eight to 8.5 hours is the average length of the shift. So this is run, I think, every 14 days. This Liverpool Street to Norwich shift. That does 287 miles in that shift, 13 reverse moves, and it covers 739 sets of points, right? And it doesn't cover Liverpool Street Station in its entirety in one shift, because that would lock things up. This is all done on days. It starts at around, I think, about 10 o'clock in the morning and finishes something like 8 o'clock or something like that at night. I forget the exact time. And all done on days between passenger trains, and to cover Liverpool Street Station in its entirety, there's 3 working timetable shift paths that does that in, and it covers the whole station. So it proves that it can be done, and you mustn't take no for an answer. never get anything
Yeah,
happening.
if you could do it in Liverpool, so you could probably do it anyway.
I think you're absolutely right, yes. So, do they do what they were intended to do? Well, the first thing is they were delivered in 7 months. So the first one hit the rails in 7 months after being given that challenge. So obviously that isn't 6 months, but I still think I would take 7 months as being a success, shall we say. It does allow you to inspect the S&C from your desk, and the standards now permit that. The only thing is, at the moment, they only allow you to use it for alternate inspections. So you have to do one manual one, and you can run the train. One manual one, and you can run the train. Trying to push that to go to 3 out of 4 in certain areas. I think we will get there. I think particularly as they're rolled out to more routes and regions, and there's more people using them, and there's more end users pushing for that, I think that will allow that sort of increased frequency of train usage to coming to the fore. They're not suitable for everywhere though. So if you've got a full head layout on timber where you have 50 keys coming out every week, there's no point sending a train there, is there? Because that train can't knock them keys back in again. So they're good if you've got a layout with reasonable good maintenance history that doesn't need people tightening up bolts or knocking keys and clips or whatever every week. Locationally accurate, as I said at the start, very important thing that we know exactly where they are. They are down to sub 30 millimeters locational accuracy now, which is really, really good. And that's consistent as well. It's not dropping in and out every time it runs. That is accurate down to 30 millimeters. And the data, so once that runs, the data is on people's desktop generally within 2 hours. So as soon as that's done its run, people can view that data within 2 hours, not 24 hours, 2 hours. In one instance, that was 19 minutes, I think it actually got to people's desktop, but it's
better than patrol.
It is exactly right, and you can see everything, of course, well, but generally it's there within 24 hours. And the way that sort of works, I intentionally haven't included lots of footage from Ava, which is the sort of viewing tool, because I wouldn't be able to do it justice. If anyone's particularly interested in that, let me know, and I can get someone to give you a bit of a demo of it. It's worth looking at, but I will not be able to give it justice. But the way that actually works is that mimics the way that you do a manual inspection. So you sit down in front of your screen, and it takes you through at walking speed the route that you would. As you go through it, you make your notes on what's wrong and what needs to be attended to, and then when you get to the end of it, and you have to wait until you've got to the end of the full patrol because it won't allow you to do this beforehand. When you get to the end of it, you press your button and the TEF form is generated automatically, and then it gets sent to the section manager, whoever that goes to sign that off. So it's all recorded and generates everything automatically. The kit has been incredibly reliable. There's been a few instances with generator issues, and we've had one issue where the Vista track geometry system went down for a period of time as well, but generally pretty reliable. The trains, within the first few weeks of them running, had a bit of a nightmare, but since then they've been very reliable as well. And certainly, don't quote me on this, I could get into a lot of trouble, I would happily say that they are by far the most reliable IM train, by far at the moment. But they are designed as a passenger train, so they're not going to be.
So how many? I mean, again, I think some of the problems with the IM flex is it only gets used occasionally. So these are presumably in use 7 days a week, or
5 days a week. Yeah, so generally sort of 8+ hour shifts as well.
so like a service train now.
Exactly.
Continue.
Yeah, I mean, from the train's perspective, they're being used in a very similar way that they were designed to be used as a passenger train. They're not sat aside and idling for hours on end or anything like that. So yeah, I think that sort of that helps. So, but of course, if you give someone a tool, they tend to use that in a very different way to what that was originally intended to. So my son had a Lego fire engine for Christmas last year, I think I spent most of Christmas Day building that Lego fire engine, but by Boxing Day, of course, that had been turned into something very, very different. And of course, it's the same with the 153s. So what else have they been used for? So covering IM runs that are filed, bond and inspections. This was a Wales and Western one, so there's a number of issues between, I think, Paddington and Didcot, and there was a requirement to understand where bonds were and what condition they were in. So the train was sent up there to gather video imagery of all of those bonds. Support and supervised inspections where there's been some issues with resource. Inspecting specific assets of concern, so culverts or flood areas or stuff like that, and also identifying asset types. And that's what I'm going to bring on to now. How are we doing for time, Ellie? Fine. Okay. Right. So identifying different types of assets. Scrap rail down here. So real opportunity is, like I said, is exploiting that data gathered. The train is going to carry on doing what it does, and the camera's picking up that imagery and the geometry system picking up the geometry. But once you've got all that information, the real opportunity is exploiting that in that what you do with it. And Eastern, One Big Circle, who are the company that provide the cameras and the viewing tool, have been doing a lot of work with machine learning. And here's sort of some examples. So scrap rail is one. So the system now, if you look on that left-hand picture, you'll see a little green square down the bottom there. As it runs, it automatically identifies rail. Let's not call it scrap rail yet. It automatically identifies rail which is not running rail. So you can then, rather than scanning through hours and hours of footage, you can press a button and that'll come up with a list of all of the rail that isn't running rail on your patch. That'll give you a photograph of it and I'll give you a location of it. So then you can add notes to that to say what that rail is, whether that's scrap rail, whether that's strategic spares, whether that's whatever. And you can basically generate, if you're doing a campaign clearing up scrap, or you want an inventory of all your rail that you've got stored strategically, you can produce it just like that. I mean, that is literally, we're talking 30 seconds to do that. Imagine how long that used to take sending someone out to do that when there was a concern about the storage of rail. But that happens every few years, doesn't it? Train plates a bit of rail that isn't stored, probably, let's send someone out to find out where all the rail is. Now, that can literally be done at the touch of.
It keeps itself up to date.
Absolutely keeps itself up to date as well. So that's scrap rail. Lower ballast. So another sort of algorithm, I suppose you call them, that they've generated is around automatically identifying areas of lower ballast. So again, you don't have to trawl through all the information, you just press a button and that'll show you all your areas where the computer, the machine, whatever we like to call it, thinks you've got low ballast. And I've also incorporated into that a very sort of quick way of calculating, well, how much ballast would I need to order to do a drop over this area as well. Wet beds. So automatically identify wet beds. See the little green squares around them again as well. So it's looking for certain features that associates with a wet bed. So again, press a button, show you where all your wet beds are. No need to trawl through all that footage. And of course, you can also look at how things change over time in a matter of seconds as well. Train's been running around for 3 years. Literally go from one photo week by week by week, or 14 days, or monthly, however often that's running, and you can see how your wet beds have changed and they've propagated or whatever over that period of time, how they've changed seasonally as well. Rail joints. So that shift that I mentioned between Norwich and Liverpool Street, on that shift, how many miles was it? 287, something like that, I think. 6,000 rail joints identified in that shift by the train automatically. So not someone not having to trawl through anything. Literally the train identifies where all those joints are. So you've got the location, a very accurate location, and you've got a photograph or 3 photographs effectively of each joint as well. One looking down on it and one looking from either side. The system can now automatically categorize those joints as well. So is it an IBJ, is a 6-hole IBJ, is a plain joint, whatever. And I'm not saying that you never need to send people out to look at joints again, You can send them out to look at the 10 or 20% that actually really need looking at, rather than the 80 or 90% that look absolutely fine. Particularly sort of hot weather prep and stuff like that, where you really want to send people out to the things that are concerned rather than the things that are absolutely fine. And of course, if you've got an image of it and you know exactly where it is, gives you half a chance to do a little bit better preparation in terms of, well, do I need some plates, or do I need this, or do I need that, or have I got some strategic spares nearby or anything like that, so people can actually plan to do the work before they get there. You can also take measurements as well, so again, handy for hot weather prep. As you can see there, rail gap of 16 mil. It's not just rail gap measurements you can take any measurements that you should happen to want to take. So expansion switches, switch openings, anything like that as well.
That's a potential game changer for some of the sections with lots of jointed trackers. Colleagues here will know measuring the joints in 80 miles of jointed track is a very back-breaking exercise. So to be able to automate that process is a real.
And to have all that data to your hand as well. So that was all about sort of identifying asset types. Then we sort of move on to actually, can it automatically identify defects and categorize them as well? So with joints now, it can actually prioritize joints for attention. It's not telling you what to do or anything like that. It's saying, well, I've seen this joint, I've seen these features, here you go, you make a decision on what needs to be done about it. So it can automatically identify cracked plates, it can automatically identify any pumping around the joint, any missing bolts or any rail impacts. Again, must be quite helpful for sort of doing campaigns, utilising resource effectively and utilising possessions effectively as well. Crossings, again, pretty sort of standard there, any damage to the crossing contact area, that again will automatically identify that and flag it. Clearly, it's not going to see a crack in the crossing foot or anything like that. That still requires someone to go out and look at. But again, it gives will give help to prioritise those well repairs and whatnot as well. Here we see a sudden change in the running band that's been identified automatically again. Sort of suggests an area potentially of vertical longitudinal splitting, and I think that rail was actually removed, and that was confirmed as being vertical longitudinal splitting again, which historically has been quite challenging to identify.
Well, certainly we've tried looking using automated systems before. It's been problematic doing it. Yeah, and they're not easy to spot. So well, that's fantastic.
And then finally, it's actually identified a couple of broken rails as well. So obviously we aim not to have broken rails, but we still do. Both these brakes were identified automatically, not by a VIU, I hasten to add. So we have a UTU train, which has exactly the same camera technology on it, which feeds into AVA as well, and the same system, everything. So this is the same cameras, but on a different train. But the algorithm that was developed for identifying broken rails was in response to a number of breaks that had been occurring on Eastern again. Implemented that pretty quickly. Train goes out and is in this case, or I think for both of these actually, was the primary identification sort of mechanism for these broken rails, in that was the first thing that identified them, and identified them pretty quickly as well. Clearly, we shouldn't be relying on that. Clearly, we shouldn't be having broken rails as well. But if you've got a train running around with that capability, why not, utilise it? I think that's the sort of the clear thing there. There's still some more in the pipeline. Like I said, we fit similar cameras to one UTU. Very, very keen to roll that out to the rest of the UTU fleet as well. We also have one UTU with rail lock fitted now as well, and very keen to roll that out to the rest of the UTU fleet.
Yeah, Dave Clements locally has been, many of you know Dave, he's star rail manager.
He's been very vocal that he
really pleased with what he's getting out of that.
So I think we're confirmed now that we're going to be rolling out the camera arrays to the rest of the UTU fleet. Still got a bit of work to do with the rail lock, but basically those two systems come together. That's when you get the real benefit. There's also, which Dave Clements has been an advocate of, is the fault navigator system, which basically takes, because we know exactly where the faults are with this to a few millimeters of accuracy. There's now an app that's being trialed on your mobile phone, which takes you directly to the fault. So if you go on at an access point, they'll say, well, that's 275 meters that way, and that'll literally take you right to it. I'd like to sort of roll that out further as well. Point cloud capability is another one that we're looking at. Could we utilise the 153 fleet with point cloud survey equipment on there? Would that sort of stack up? Potentially overhead line camera. Obviously, these haven't got a pantograph on them, but still, if they're running around, cameras are pretty cheap at the end of the day. So you stick the camera on the roof. Could that be beneficial to the overhead line community, just to give some video imagery of that? Structures camera, that's been in use on Southern as a trial for a little while now. That allows you to do some of your annual visual structures inspections from the safety and comfort of your desk, rather than going out and think with binoculars and what have you. But I think the key sort of takeouts for me for this is so important to get something, and that's very half decent. There's obviously no point sending getting something rubbish out there. If you get something half decent out there so people can use it, you don't wait for it to be perfect. Get something out there and people will love it and buy into it and feedback and give the opportunities for improvement and all that sort of stuff. And I really do feel that in the railway we spend a lot of time trying to perfect things and deliver nothing. And it's so important to get things out there so people can grab them, touch them, feel them, exploit them. Involving the right people from the start, absolutely vital as well, particularly the end users and particularly the supply chain as well. Give the supply chain some space to blossom and work in, rather than sort of being very sort of dictate exactly what you expect from them.
The experts, aren't they?
They are the experts, yeah. I think seeking that feedback and commit to act on them. This particularly comes to the drivers. So we spoke to a lot of drivers. Said, "Well, how could we make this better? How could it work better for you?" And that, and they came back with quite a lot of comments, but they didn't think we'd do anything about it, and they were absolutely blown away when they got a fridge and a nice kitchen area and some nice seats and tidied the cab up a bit. So if you seek feedback, you make sure that you do act on it. Yeah. And that, as I said about Liverpool Street, that will never work. You can't do that. Use that to your benefit to actually drive a sort of high-performing collaborative team, because some of those challenges you do get a little bit of a buzz out of proving people wrong, and that you can actually do these things as well. So, thank you very much for your time. There's just one other thing I did want to end on. There possibly will be an opportunity at some point when it arrives on Wales and Western, if you're okay, Andy, to do a bit of a tour round on one. So if you want to collect people's names that might be interested in that, when that does come around, I will get in touch and we can go for a little ride out and you can see it sort of, in use. Thank you.
Well, I'm sure we've got some questions. Have we got anyone online?
Now we've got about 7 or 8 questions.
Well, start
Are
with
you ready, Marky?
Start with those.
Right, I'll just read them straight out. Right, so Alan Weston was the first one. Being a class 153, are there any issues with traction, stroke, adhesion on steep gradients?
There hasn't been to date. We haven't had any issues with wheel slip or wheel damage. The drivers are, I suppose they drive it quite defensively, because they're doing a lot of stop-start driving. So so we haven't had any issues now. Probably the benefit of having a generator on board, which is a fairly hefty piece of kit, they're reasonably loaded all the time as well. So no, we haven't had any problems.
So they behave slightly differently to as
the passenger ones. Yes, I think this is again has at the end of the day, the way you drive a train has a massive impact on the amount of slip slide action that you get, doesn't it? So yeah.
Okay.
Any questions in the room?
I've got one on the data. There must be a hell of a lot of data that you're storing from all these trips. So how do you go about managing that?
So that is all done by One Big Circle. So I don't do any managing of that at all. A lot of it is processed on the train. So the amount that then goes off the train isn't so significant, but clearly there's video imagery makes up a whole, there's big data chunks there. So if I'm absolutely honest with you, I leave that to One Big Circle to do, and that's within their contract to manage that data and keep it available for a certain amount of time. And that's a reasonable amount of time. It's not like sort of 6 weeks, that's like 5 years or something like that as well. So,
Yeah.
I mean, I imagine there's much cheaper ways of storing data now than there was a few years ago, wasn't there?
Yeah, changes all the time.
Yeah, and I think I know there's a discussion going on within Network Rail about whilst it's very tempting to want to keep it all, of how valuable it is. You know, if it's already 5 years old, how valuable it is, or you just want to keep samples of stuff and things like that. So, but it is recognised. I think the environmental issue of storing loads of data has certainly come up as a real issue. You know. Okay. I've got a question. So would you like to say something about how the machine learning works? Because I've been really impressed about how quickly, I'm not asking for a technical, no, I won't get blown in mind anyway. But I mean, one of the reasons it's been so successful is the One Big Circle thing, and how quickly it learns as well.
Yeah, so how they've been so successful is that the more images that they can get of a specific feature, the quicker they can get up to that 99 point whatever percentile accuracy level. So, and joints was a really, really good example. So Eastern were really, really interested in One Big Circle and developing this joint inspection capability because they saw some real sort of benefits of that. So they provided, One Big Circle gathered the imagery of the joints, and then they provided a lot of engineers to give them basically information about what was good, what was bad, what was indifferent, what type of joint it was. So if they can suck that information in, they can very, very quickly develop a sort of an algorithm, if they've got lots of images, that is pretty accurate. And that's why the broken rails one has been slightly challenging, because obviously there's not that many pictures or photographs.
And there's a lot of variation as well.
Exactly right. Exactly right. So that's why I wouldn't say that particular one that was identified was lucky, but I imagine in the background there's probably quite a lot of false positives that are still coming through with broken rails. But joints, because there's so many of them, and the engineers were really bought into providing them that information, they were able to quickly develop something that was, well, very accurate at the end of the day. Yeah,
that's the big change, I think, from when we did PLPR, when we were using creating models of what things ought to look like. So the teaching process was really, really slow. Now all you need to do is give it images and away it goes. It supplies now. Right, do you want another one from model?
Yeah, sure. Emma Holst asks, moving cameras to under the train, does that mean there is no longer a patrolman's view?
No, sorry, I didn't probably explain that very well. So that the only cameras that were moved under the train were the ones that were looking directly down onto the rail. So the forward-facing video, which is both on the front and the back of the train, and also the thermal imaging cameras, both still give that sort of patrol person's type view.
Okay. Anyone questions in the room?
Can the train work in both directions?
Yes, it can. Yeah.
Yeah, so we talked about it's Liverpool Street that actually prompted the development, and we talked about the NPD, which was never intended to, it was only ever intended to be a test bed, was a vehicle that could run in and out of stations, so you cover all the routes. It's because with the normal recording fee, you only cover a selected number. It's based on what they've been doing in Holland for a very long time. The challenge has always been, till recently, is to get it to operate as a timetable service, as opposed to running on best endeavours. because that's the thing. But that's what this is really meant to do. So you can, because you can go with the one coach train and go right up to the bus stop as well. Right? Whereas the NNT, you might stop recording halfway down the platform. Yeah, so that's one of its values. So, right, any more questions in the room?
LiDAR and voids and things, is it gonna keep going, just in developing?
I didn't hear that, sorry.
Things like LiDAR or avoid under the track or something, there's something further again than currently doing, just visual. So that LiDAR, LiDAR, identifying voids, so it's not particularly necessarily visible.
So
But could be
what
picked
the
up.
cloud is a better version.
Yeah.
Which is definitely being looked at in terms
Yes.
of GPR data, and this GPR scanner on there yet in terms of what we're looking at, but that may be an evolution in the future.
Yeah, so the TRU replacement has got the radar on it. The 153 VRUs happens, but we think potentially if you put a point cloud system on there, that would give you some idea of your voidings. You've got then the point cloud system is sort of looking slightly ahead of the train, and then you've got the geometry system actually on the train as well. You could be able to sort of calculate some differences between what they're seeing unloaded and what they're seeing loaded, basically.
Yeah, calculating the difference between unloaded and loaded.
Yeah, I think that's
Shed loads of data. Yeah, I think it opens a future. Another one online.
Yeah, Jeremy Rees asks, is there a reliability issue with a single engine unit?
That is why the TCMU and the TRU are both two-car trains, because we were slightly nervous that there was an issue with a, and clearly that is a single point of failure. So you would think that a two-car train would be inherently more reliable. But again, touch wood, and I'm thinking this Vandal's now going to do something like to stop the single-car train as well. But touch wood, today, we've had one failure in the early days of where that was a complete failure, but since then we haven't actually had one sit down. So I think because they are so simple, if they're maintained properly, they should continue to run and be reliable, basically. But yeah, sending a train all around the country, which is what the TRU will do, that did feel that was right choice to make that a two-car rather than a single-car train.
You're gonna look to put in to electrification to go on one of the pantographs, so speak up, please. Are you gonna look to put in with the pantographs to electrification?
I think doing that with a 153 would possibly be a bit too far. I think to do pantograph type inspection, so looking at the wire geometry and pan accelerations and loadings, you really need to convert a train that is already got a pantograph fitted to it, because even fitting a dummy pan and the risk of it staying up when it should come down and things like that is quite a challenge. So I think a similar type, I forget what the class of train is, but there's similar EMU type trains like this, which are obviously have a pantograph fit from the start. That would, I think, would be the sort of the ideal test unit to trial.
I think it's worth saying that all the new generation of trains, so the Class 800s around here and other trains, they use on these guys, do have pantograph monitoring on anyway. So they have a video system, and I think they have some sensors which measure contact pressure and things like that. So we're already going down that route again. They're just in service trains, so I think that's
Yeah, I suppose overhead line sort of inspection does tend to sort of be supported better by in-service monitoring rather than a bespoke standalone train. So with the 153s, I mean, you can never do what that does on a passenger train because the passengers will be running in and out of the platform about the station about 10 times. Whereas with overhead line monitoring, you're not doing it so frequently. So if you do put that on the right number of passenger trains, you are tending to sort of cover those some fairly sort of significant areas with that. And also I think there's requirements around overhead line monitoring that means it has to be done at speed. So you get a representative behaviour of the pantograph, whereas with the track, the speed is not so relevant really.
Yeah, Mike Liscombe asks, I'm presuming you have the unit dynamically gauged prior to the physical gauging runs, or did you rely on the original Class 153 gauge clearances on routes where it was already clear to run?
No, so that because they've been loaded up with a lot of equipment, what have you, we had them dynamically gauged before we sent them out.
The big challenge with the 153s in the region, they reduced the course gauge volumes, was the passenger steps, which were a modification after the train went in service. And I think they were all slightly different as well. So by removing those, so they've got the crew steps, but they haven't got the passenger steps anymore. That has actually got rid of a lot of the problems because they're quite good clearance because they're slab sided, they're relatively small trains. So, yeah. But I think it exists the gauging model now. You can check that as one of the vehicles.
Yeah.
Oh, any more questions?
So, are you going to add like laser scanners to it as well to do?
That's what we want to do, yeah. So Scotland are very keen on the laser scanner system. And if we will sort of work with them to put a business case together to do that. And if we're successful, then we would want to then roll that out to all of the trains again, to everyone that's got the sort of same capability. But I think, obviously I'm biased, but I think that's to build the vehicles with that capability. You don't have to spend millions processing all the data. You just process the data that you need. But if they're going around collecting that data all the time, and that's got the system on there, the biggest cost is really the processing of it. So you, through sort of intelligent decisions, you just process what you need, don't you? And the actual physical fitment of that equipment isn't that significant, really. And I think there was just a question then on the overall cost that I just saw pop up on my screen. So the cost is around about. So with the first ones were cheaper because we didn't do the overhaul. We were doing that sort of bare minimum approach. Now with the overhaul, all of the equipment and the latest modifications, it's around about £1.8 million per train.
So, but you're getting a train which is pretty much then guaranteed to be designed to give you 10 years. But it won't be.
Now, obviously, on top of that, there's operational costs, there's maintenance costs, and all that thing. But the sort of capital investment around about £1.8 million per train.
Questions online?
Yeah, a few more. Craig Cavard, when you say data is accurate to within 30 millimeters, what is this 30 millimeters in relation to? So he's asking about whether it's GNSS, absolute accuracy, or a given mileage from features. That makes sense.
So contact me and I will get someone who can explain it much better than I can.
I think
so, yeah.
Sort of features because it's using the real
Yes,
right, yes.
That is that, but I can. Sorry, what was the gentleman's name?
Craig,
you sound as though you were actually quite an expert in that area anyway.
Yeah.
So if you give us a shout. My email's on the last page of the presentation, and I will put you in contact with someone who can explain all how it works and everything. Then, and that will be far more beneficial than me trying to make it up as I go along.
he says he'll drop you a note.
All right, okay, yeah, lovely.
That's the world's most do you contribute to it or
Well, it's a money,
but it's a refunding.
there is a distribute first and purchase, so it's a procurement of the region getting that.
The initial sponsorship came from Southern, who had their problem, as you saw right at the beginning, with the accident at Surbiton and things like that. They felt they really needed to do something. They've also got an awful lot of S&C. So and the Eastern also got involved in it. I think it's probably not unfair to say that some of the other routes still back to see how they got on, I think, isn't it?
Yeah, that was the case.
I think people did that, but now we've demonstrated this is it, so other people are now coming on board. And clearly Scotland wants to develop it on into other things as well, so, yeah. Okay, any more questions in the room?
Yeah, I got one. How do you get around a crossover if you're only recording, I guess, the up and the down, what about traversing to the?
But we go all routes. So you've got,
I think you
yeah.
split pairs, stuff like that, and the inspections are modular, which you tend to be up to 6 foot.
Say that again.
Split pairs, modular split pairs.
It'll go the up, down and.
It will,
Yeah,
everywhere.
yeah, so, yeah, basically every we sort of build the diagrams up from your patrol routes, and that will cover basically every direction that you can go through.
That's the real difference between the normal
Yeah,
conventional track recording thing. It's what the MPV was designed to do, was to go in and out of every platform and through all the crossovers and everything, and that's what this constant set allows us to do. And the positional accuracy is going to be a game changer with that as well, because sometimes it was a bit difficult to pick out where you've been
Yes,
with
yeah.
the MPV, because you just got a trace which was what's it fits.
yeah. Well, if you're like, not within 5 meters of where you are in a throw area, you could be on a few tracks, couldn't you?
You could potentially be on a different track. Yeah. Right, any more online?
Two more.
Go on then.
So Alan Whiston asks, from the AVA footage, I assume the VRUs have fixed AVA cameras installed.
Do you mean forward facing views?
Presume so.
Yeah, forward facing.
Yeah, so
Standard AVA cameras.
the downward facing cameras and the forward facing cameras are all AVA cameras that feed into AVA as to, well, yeah, everything on there feeds into AVA.
They're all fixed into the same position though, aren't they? I can pick them up.
Oh, no, they're all permanently fixed, yeah. No, so I think that, I know where you're coming from. So you're thinking about the cab mounted cameras that have been used on some of the locos. Now, these are all permanently fitted cameras that are, hardwired into the units and automatically turn on everything. So there's no relying on a driver sticking on the windscreen or turning it on or anything like that.
So from a driver's point of view, it's just a
They just drive.
They just get it, turn it on,
Yeah,
do it, go with a timetable, tells them to go and bring it back to somewhere, that's it.
with a kitchen.
Yeah, with a kitchen, a comfortable seating, and a fridge for the milk.
Yeah.
So, okay. Michael, want to take the last one?
Last one is, so Mike Liscombe says the image is fantastic, which I guess the resolution, which I think we all would all agree with. And then he asks, from experience, the new cab, the 153, was smaller than the original cab when the units were 155s. I'm very uncomfortable. Have you managed to do anything about this? I think it's for the drivers, wasn't it?
Yeah, so with we've changed the door. They can basically drive them along with the door that separates because the cab was sort of effectively split, wasn't it? So we've made the cab that's very, very small, so you can actually drive it along with the door open. So that's much more spacious in there. Haven't actually had any complaints from the drivers about that particular cab. I think that was more of a case when they were first converted and you went from a sort of full width cab to effectively a half width cab.
Okay. So there's one more just from Andrew Wilson. Are the trains ready for ERTMS?
No.
Not yet.
Again, I mean,
Oh, sorry, not ETCS. ETCS.
No, ERTMS.
Yeah,
Because our Cambrian route is ERTMS.
No, it's not. No.
there is a multifunctional solution being designed, because they got one you can put on a steam loco now. And they've got one that's been designed with vintage traction in mind. And I think the big issue is where you put it, isn't it?
So we have we've been to just on the ETCS rather than the ERTMS. We've been to the East Coast Digital Programme with a proposal which was to fit the EIU replacement with ETCS, which they endorsed. So that was fitting 4 cabins, 2 units, which way they endorsed, but they haven't actually got any money. So whilst they thought that was the right thing to do, they haven't got any money to fund it, and that's where we are at the moment. So recognising that these are a solution for 10 years plus, Network Rail recognises that ETCS will need to be fitted to them, and a first class fit design and everything will need to be done, which doesn't come cheap. Probably sort of £5 million plus something like that. So that's endorsed as the right thing to do, but we just need to find someone with deep pockets.
Right. Questions?
Just one comment. I assume these 153 still have their original track brakes, just as they did with 155s. In some respects, there are slight advantages of track brakes when it comes to slipping, as opposed to disc brakes.
Yeah, keep the treads clear. Don't
Yes, brake blocks do that for you.
Yeah, I think that the concept was, correct me if I'm wrong, was to do as little as possible to the train. Because obviously the train has already got a safety case and everything else. So that it just focused on the new equipment you need to fit on the train rather than doing any modifications to the train to change. So things like putting the generator in obviously increases the weight, you need to do that. Putting the cameras on needs to do that, but not fiddling around with the actual kit itself. So, right. So, there's no more questions. Can I call upon James?
Sure.
Thanks.
Well, thank you, Mark, for braving the aftermath of the storm and making your way all the way to South Wales. It's been a fascinating talk. It was originally, wasn't it, for geometry and for S&C BVIs, but it's been fascinating to hear about your approach and how you've developed something that's really exciting, could be a real game changer for us. And I can understand why you want to get it out there, because it's becoming like a sweet shop, isn't it, for infrastructure engineers, where lots of people want to put lots of things onto it, which shows how much it's needed. So yeah, looking forward to it coming to Wales. Can't wait. And thanks very much. So if everyone can join me, thank you, Mark, in the usual way.
Right, just before I close the meeting, has everyone signed the attendance sheet? Okay. The notes of the last meeting were circulated with the agenda for tonight. Are there any issues arising from the last meeting? So take that as a true record. So the next meeting, something completely different. That should be now 13th of January. And we've got Paul Keating coming to talk to us. He leads up the team which does continuous improvement. So within here, it's the Wales route. So he's going to talk about continuous improvement, some of the things we've been doing in-house to try and foster that kind of an attitude to things. So, and that'll be on the 13th of January. Okay. And if anybody's coming for adjourn for a pint in the Bed Squares, we'll be heading up there after the parks. Going to join us as well. So, okay. So, thank you very much. You have to declare the meeting closed. Thank you. Excellent. Your Christmas is all explained for so.